Hello, I'm Rajiv, and today I'm going to talk you through my do-it-yourself Wikipedia RAG implementation that I did for homework 3 in AIPI 590. At the end of this presentation, I'm going to walk you through a brief demo deployed on Streamlit that is fully publicly available. So if you follow the URL that I show at the end, you can even access it from your own local machine. But my main objective for this homework was to power a chatbot through Wikipedia. And as we've learned in class, I was going to use RAG to do this, or retrieval augmented generation, because RAG enables information retrieval for generative AI models. And because, you build in this new functionality of retrieving information, this provides the foundation for building a chatbot. So I wanted to build a tool for people to explore basic RAG functionality, kind of like this assignment was intended to make me do. And so I thought it would be fun to design a tool that taught me about it and also could help other people learn about basic RAG function. So my deployed app serves two purposes. The user can scrape various Wikipedia pages to build a vector database, and it could be just one page or several pages, and all they have to do is input a title of a valid Wikipedia article. And the user can make queries that the model answers via the database. So once the user has accumulated all the Wikipedia articles that they would like in their vector database, then they can make queries, and then presumably the model would answer questions, that the user poses given the information in the Wikipedia articles. So data collection involves scraping text from Wikipedia, as I just talked about, right? The user first inputs a Wikipedia article title into the Streamlit app. Then the script scrapes text from the corresponding article. And what happens next is the text is actually chunked. So once this, and as we talked in class, right, this is basically a step of dividing the text into smaller manageable segments. And this is critical because it not only improves that processing efficiency, but it ensures that each segment can be effectively analyzed later on. So chunking is a very important step here. And the last step of this specific part of the pipeline is the embedding. So these chunks are embedded using SBERT or sentence BERT. Embedding this text is critical because it allows us to perform similarity searches later on. And by converting this text into vectors, we can compare pieces of text to determine how closely they relate to a user's query. And this becomes particularly useful when the user actually makes a query and we, have to return the most relevant information in the collection of data that we have. So the pipeline after SBERT and we make these embeddings continues via that retrieval mechanism. And we use the Facebook AI similarity search, or the FAISS, to store and index these high dimensional vectors. FAISS is designed to handle the search and retrieval of similar vectors very efficiently. So we figured it would be a good thing to, or rather, sorry, I figured it would be a good thing to use FAISS here. So the embedded SBERT vectors are stored in the FAISS, and when a user asks a question, the FAISS quickly scans the stored vectors to retrieve the chunks that are most semantically similar to the user's query. That rapid retrieval ensures that the chatbot can access the most relevant pieces of text from the database, even if the database contains a large volume of information. So this step is the backbone of the overall retrieval mechanism. And once the FAISS retrieves the relevant text chunks, you have to actually generate the response. And this is done with the Google FLAN T5 LLM, which is fine-tuned for generating structured fact-based responses. So it takes the curated context and formulates a response that is pretty coherent and informative. Although as we'll see, it's not always perfect. But this is the end-to-end pipeline described here, right? You start from the beginning when you have the user input this Wikipedia article, text is scraped, it's chunked, it's embedded, and then you actually end up adding all those embeddings to the FAISS and then querying the FAISS to figure out the most relevant information that the chatbot can give you for whatever question or prompt you give it. So in terms of performance evaluation, it's pretty crude in these stages, but I think it's insightful in learning how we could improve the model's performance overall. So I assessed its latency in a crude manner. I just, observed how long it took to respond to different prompts of varying complexity. And even for simple prompts, the model took many seconds to generate even very short and simple responses, which is the majority of responses it generates are not complex at all. So because they're so simple, they could likely be generated much faster. The other thing I crudely assessed was the accuracy of the model, and I found that it gives factually accurate answers to short and simple questions. And it is more likely to give a more accurate answer if the Wikipedia articles you're scraping are long and dense and informative. You scrape a short Wikipedia article, it doesn't matter if you ask a very specific question, you're still going to get low response accuracy from just a low density of data. And the third thing that I wanted to note in the accuracy assessment is that the model certainly fails to understand queries that become slightly more complex than asking what is XYZ or how does XYZ work. So it becomes tougher for the model to put together coherent responses when you make the reasoning more difficult, which makes sense because this uh, pipeline here is not designed to deal with pretty advanced reasoning. So now we move to the demo portion. Yeah, so you can see here we've got the main Streamlit user interface. I can enter any Wikipedia page name, so let's go ahead and enter human. So, okay, we have stored 21 chunks for topic human, and now I can ask, something like, what is a human? And let's see what the bot says. And I'll, you can note it takes it takes several seconds to run this, and this is something that could easily be improved, I feel, if I optimized uh, the RAG performance here. But it should soon read out an answer. Yeah, here we go. Humans are multicellular organisms that are multicellular in structure and function. Not, maybe the the best answer, but it's an answer, right? And we can scrape, we can scrape a variety of things. We can also scrape the cat Wikipedia page. Um, right. We could even scrape the retrieval augmented generation page. See, we have a lot of this stuff now. And someone could scrape this for something medical, right? Like if they wanted to learn about diabetes, you could scrape for diabetes, you could scrape for something like cancer, right? And now all of these Wikipedia articles have been scraped and stored in the vector database. So if I ask it something about diabetes, right, even though it just answered a question about humans, or well, not rather not, but yeah, what is diabetes? Again, you'll see it takes some time to process this. Yeah, and my guess is, I mean, well, there we go. Yeah, okay. So diabetes, yeah, is a disease characterized by presence of high levels of glucose in the blood. Pretty good. I mean, it's this is just a little bit of a demo of the functionality of this kind of RAG chatbot that I've got going on here. But as you can see, the latency leaves much to be desired, so there's certainly room for improvement. But yeah, thank you for watching my demo and listening to me talk about my pipeline. I hope you enjoyed this presentation, and maybe you'll get some interesting use out of this Wikipedia scraping chatbot.